Our focus in lesson 5.4 is basically on being able to multiply radicals together. And those radicals might just be a single radical times another single radical, or it might be such that we need to distribute a radical to everything in the parentheses that follow it. And then we'll also talk about how we go about rationalizing the denominator of a fraction that has a radical in it, but not all by itself. And you'll see what I mean by that when we work through an example here. So in this first example, we're just going to start with multiplying a radical by a radical. What we basically do is we take the numbers out in front and we multiply them. So we'll be taking 2 times 3. And then we take the radicals and we multiply them. So we'll be multiplying root 3 by root 5. And what we end up with is 2 times 3 is 6. Root 3 times root 5 is root 15. That cannot be simplified using the methods we've learned about previously because there are no perfect squares like 4 or 9 or 16 that divide evenly into 15. So that's our final answer there on part A of example 1. So we'll use the same method here in part B. 3 times 5 is 15. And root 8 times root 2 is root 16. But we do note that 16 is a perfect square. So the square root of 16 is 4. That we call it the principal root. So for our answer, we'll have 15 times 4, which gives us a final answer of 60 here in part B. Here in part C, same idea. 7 times 3 is 21. And root 6 times root 8 is root 48. But now we need to simplify. 48 is not a perfect square, but if we think about our perfect squares, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and so on, the largest perfect square that divides evenly into 48 is 16. 16 goes into 48 3 times. So root 48 can be broken apart into root 16 times root 3. Square root 16, of course, has a principal root of 4. So we'll have 21 times 4 times root 3. And finally, 21 times 4 is 84. So our final answer is 84 root 3. Now part D is a little bit different here in that we're not dealing with square roots, but rather with cube roots. But we can go about it in a similar fashion. We're going to take the numbers out in front and multiply them. 2 times 5 is 10. And we're going to take the cube roots and multiply them. It's just that our answer is going to be under a cube root. So 6 times 4 is 24. So now to see if that simplifies, we need to make a list of our perfect cubes. 2 cubed, 3 cubed, and so on. Clearly, 8 divides evenly into 24. So I can think of the cube root of 24 as the cube root of 8 times the cube root of 3. Well, the cube root of 8 is 2. So we're going to take 10 times 2 times our cube root of 3. 10 times 2 is 20, and there's nothing more we can do with that cube root of 3. So our final answer is 20 times the cube root of 3.